Hi, this is Doug Joseph with Design Aid Studio, and I want to do a quick video to show not only framing for getting ready to cut a job, but also how to do the probe test. You may have noticed earlier I mentioned that the probe test does a pause. And the reason for that pause is to give you a chance to measure the distance between the tip of the torch and the metal. It's probably best if you had a gauge block of the right size, but I don't have a set of gauge blocks. They're kind of pricey, and I've found that a 3D printed gauge block works okay. And so I did some research on what kind of pierce height I would need, and I came up with 0.12 of an inch or 3.48 millimeters. But to get that height, you have to set your float travel distance, which is one of the parameters that will vary depending on how your floating Z end stop switch works. All of this is assuming, of course, that you're not doing ohmic testing for probing the height. So here on the main page of LinuxCNC's QT Plasma C, if I go to parameters, you'll notice that there's a probing section, and I've created a new config that has metric as the default. So now I have an imperial config that I can launch or a metric config that I can launch. And in probing, the first thing is float travel, and that number can be set as you need based on how much travel distance there is to get your floating Z to trigger. And so once you've figured out a guess to start with, then you go to the main page and you tell it that you want to do a probe test. Now I'm going to nudge my torch over on top of one of those slats, and I'm going to go back a little ways and get in a good spot there. And now I'm going to position my mouse over a probe test so that I can just touch my trackpad while I'm standing. And so I'm going to reach back and touch the trackpad, and then a probe test is going to happen. And when it does, it will probe to the metal, the floating switch will trigger, and then it will raise up, and that's my chance to test. That felt a teensy bit tight. I could get under it, but it felt a teensy bit tight. So I'm going to go to parameters, and then I'm going to nudge the I'm going to nudge 5.8 up to about 5.85, and then be sure to save your work in the upper right, in the upper left hand corner. Then you can go back to main and give it another probe test. So we're going to again use my 3D printed gauge block, and I'm going to once again do another probe test. My floating Z will trigger, it will rise up, and now I've got a comfortable swipe under there. So I'm now confident that I'm going to be at the proper pierce height and at the proper cut height. Those are separate parameters, and the reason why they are separate from the float travel parameter, they're over here on the other side, and they can be material dependent. So you start off with a default material, and then you can add. The default material is 0, 0, 0, 0, 0, and then you can add other materials. So far I've only done cutting in 20 gauge and 18 gauge. This particular project is going to be cutting in 18 gauge, so I'll choose that. And you'll notice things like kerf width, pierce height, and pierce delay, these can be material dependent. I've noticed that my kerf width seems to be a little wider than what I had set earlier, and so I'm kind of experimenting until I can get something that is dimensionally accurate. I'm trying a kerf width of 1 millimeter now, and I'm going to go ahead and save that, but I believe that when the kerf width is set in the posted G-code file, I believe that gets honored over above this, as well as the various different feed rates and speeds. But I try to keep them matching as I can. So I'm going to go ahead and change the kerf width for the other materials, both the default. Well, the default was already at 1 millimeter, and so I've got 20 gauge and 18 gauge set to 1 millimeter now. Save all my changes. I'm set on 18 gauge. Gonna go back to main, and we're going to do a framing test. So I'm going to position my mouse over that, and then when I tap the trackpad, we're going to get a framing test. And so it is now running the bounds of the job. And by the way, if you have a config that is based on Imperial and you open a G-code file for a cut job that has millimeters set, it will be smart enough to honor that for the cut job. But the version of Qt Plasma C I'm running is not smart enough to honor those millimeters for the framing. And so if you hit framing and your torch barely moves, that's because it's trying to do, say, 14 millimeters instead of 14 inches. And so you'll either need to switch to a metric config or re-output your G-code file in Imperial. So at this point, we're running through my checklist. I know I've got my air compressor with power supplied to it. I know that my control box is powered up. Qt Plasma C is running. My G-code file loaded without errors. And my plasma cutter is geared up. My step-up transformer is powering it. And so we're ready to go ahead and enable the torch. And we're going to go ahead and cycle this job to go ahead and cut this art. Oh, one more thing. I need to put my mask on, make sure that I'm not breathing any fumes that I don't want to breathe.
Hey, this is future me telling you to hang in there, because later on in the video, I show you cool stuff about cut recovery options in Qt Plasma C in LinuxCNC. Okay, we're about to run into the one and only misfire that happened during this cut job, when the arc was lost halfway through a segment, and it gives me a perfect opportunity to show you how the awesome cut recovery tools work in Qt Plasma C, the graphical user interface for Linux CNC. So you can see there that the tool stopped cutting, but it kept moving. And at this point, you can hopefully reverse back through the G-code and recut that part.
Okay, so this is a perfect opportunity to show you the cut recovery options of Qt Plasma C in Linux CNC. We're looking at one of the grid sections on the globe that the arc failed about halfway through the cut, and it took a moment for the control software to pick up on that, and it kept guiding the torch through the cut even though nothing was cutting. So let me take the camera off and then come and show you here how those cut recovery options work. First of all, it kicked us into a cycle pause where cycle resume is blinking. But then we would normally have fast forward and reverse here. And so I'll need to resume briefly for a second and then pause again in order to get fast forward and resume. The concept of fast forward and resume is that it can fast forward and rewind through the G-code file. There we go. Okay. And you'll notice I'm now in cut recovery mode, and I can go in reverse through the G-code or forward through the G-code. It's helpful for you to line up where the torch is and then zoom in so that you can see up close where the torch is on what didn't get cut. Okay, it thinks it's on to the next move, and I need to get back to this one move here. I think what I'll do is skip this for now and continue cutting the rest of the globe, and then I'll remember that I need to come back to this right here. And what I'll do after the whole cycle finishes, I'll start the cycle again, and then I'll pause it, and then I'll use fast forward, and I'll raise my speed up, and I'll fast forward through the entire G-code file until I get down to around line 56,000 or something. But I'll be watching the progress over here, and when I get to this one piece that needs cut, then I will pause in my fast forwarding, and then I'll resume, and that will pick the job up and recover the cut. There's also another thing. If you catch it soon enough and you're not out of this move and not onto the next one, for some reason it won't let me back up into out of this cut job back into this one. But if you're paused and in your cut recovery while you're still in the given cut that needs recovered, then one of the problems you run into is that you can't get an arc going over a gap that's already been cut. And so what you can do is use your movement tools to nudge the torch down off of the planned line where there's still some metal, and then when you resume the job, it will strike its pierce arc there over the metal, and once it gets an arc established, it will move back to the line that needs to be cut and continue on the job. It is a phenomenal feature, and I don't know of any other CNC software that has cut recovery options like the Qt Plasma C on Linux CNC. Their cut recovery options are really, really amazing. So we're gonna get this going again and continue on with the cut. Okay, remembering what I said a moment ago about needing to go back and do some cut recovery. So what I need to do is get another cycle started and then pause that cycle so that I get cut recovery options. And there's a couple of ways I could have done this. I could have disabled the torch and then run the cycle and just stood there and just let it go. Or I can wait to pause it until it's on its way down to make a cut and then pause it and get these features, set my speed up, and let me illustrate watching this. So I'm going to be pressing fast forward through the G code, and you'll see the cutting head moving. It's moving through the G code without going up and down, without cutting. And I've got a lot of G code to go through, getting back to the one part that didn't get cut. You can see the G code moving past very quickly as I'm fast forwarding. Again, I used the up and down yellow slider there to choose a fast rate of speed. And this is a cut recovery feature. I'm moving through the job without cutting until I get to where I want to resume. Remember, we were looking for about line 56,000 or so. We're at line 12,000 now.
20 minutes later.
I'm at 53,000 lines of code, 54 and a half, 55. Okay, I'm now going to slow down and zoom in. Now it looks like it's about to go to the square I need, but it's not. It's going to the square just below the one I need. And I don't need the start of the square. I can afford to wait until it gets almost in that corner. And now what I'm going to do is I'm going to nudge down in this direction to get off the line, to give a place for the arc to be able to have a good connection to ground. And now I'm ready to resume. So when I resume, it's going to strike the arc and then it will move back to the line and then continue the rest of the cut. That's how this cut recovery feature works. It is tremendous. So let's resume. And we didn't need to continue with additional cuts, so I had to go ahead and run and pause real quick. So, but we just did cut recovery on that piece right there. Just did cut recovery on that piece, and it looks like we got a bit of it cooked a little bit too far through, and so I may have to do a little soldering to repair that bridge there. All right. Let's take this piece in, get it cleaned up, get the pieces popped out that were cut that didn't fall through, and get this cleaned up, and I'll show you what we're dealing with then. Okay, so I've just brought it in. I haven't even had a chance to dry it off yet. I've got an old dirty rag that I use when the metal is all covered with smoke to try to dry it off a little. Let me get a tripod so I can get my hands free, and we'll resume again. Okay, so our first order of business is to try to get out any of the grid squares that didn't just fall through into the water table. And usually these pop out without needing much persuasion, just like that. I mentioned before that I swing for the fence. This kind of cut job with dozens and dozens of little grid squares and little thin bridges between them, this is really swinging for the fence. I mean, this takes guts to try this, because if your CNC gets off anywhere, then your bridges are gone. Some bridges are too thick and the other bridges are non-existent. And so you really got to make sure you've got your pierce height properly set. Otherwise, you may have your tip dragging on the metal, and that is going to contribute to getting your magnetic breakaway skewed, and your cuts won't be precise. And you might say, well, why not just get rid of the magnetic breakaway? Well, as soon as you have your CNC drag that tip across a cut piece that didn't fall through and it's jutting up and it's about to chew up your tip, you'll be really glad that you had the magnetic breakaway. Okay, I'm going to get a screwdriver or something to help with popping these out. I am really pleased with how this came out. I'm going to have to get a grinder to fix this one because it was staggered off low just a little bit, and that's why part of this bridge is chewed up. So I'm going to have to use a little solder to fix that, maybe. But I'm going to need a grinder to get this part out. A grinder or a Dremel tool, I'm not sure which. To have had an almost perfect job on something that complex is a really great accomplishment, and I am really thrilled with how this has come out. So, not sure if you can see, but the one piece that we did cut recovery on, the cut recovery started in low. It didn't quite connect in with the previous cut, and the previous cut was already losing strength here. I'm not sure if this was a thing where my air compressor didn't kick on quick enough and it was getting low on air pressure. Don't really know what happened, why it was losing the arc there. But we're really close. We're really close on this. And so I'm going to try to salvage that. Okay. I am really, really glad to have so few issues on this one, and really, really pleased with how that came out. So I'm going to use a drill with a wire brush on it, get this cleaned up, and see where we are then. Had to make Newfoundland connected to the mainland, otherwise it wouldn't have been able to be on the map. And it was too big of a detail to be left off.
I'm not even a novice welder, but once I took this in and cleaned it up with a wire brush and took a grinder to it, it looked great, and I was happy with the result.
So before cleanup, I've got discoloration on the front side. I had discoloration like that on the first one, but when hitting it with a wire brush, I was able to get almost all of the discoloration off and get it looking pretty close to how it looked before welding. So I've got the back cleaned up and I've got the front cleaned up just using a wire brush on a power drill. And as you can see, it takes that bluing, that heat discoloration right off. And I haven't taken a grinder to it yet, and I may or I may not. But if I take a grinder to it, it will clean up my very amateur welds. And so I may do that. I have to put in some hearing protection if I do, because that thing is so loud. Hi, this is Doug Joseph with Design 8 Studio. If you like our content, please click like and subscribe. It helps us with the YouTube algorithm. And until the next video, I wish you happy making.